Alright, now it's time to talk about wind energy and give you a little bit about the basics of how this works. It is probably the fastest growing of all the alternative energies in the United States and in the world. Alright, this type of renewable energy has very little environmental impact, and the idea is to simply turn a turbine, which turns a generator, without burning any fuel. Alright, so we don't have to turn water into steam to turn a turbine. We're doing it by taking the energy directly from the wind. Alright, so hopefully it'll be a better choice overall from an environmental perspective. Alright, so what is wind energy? Alright, it is taking energy from the motion of the wind, alright, and converting that into mechanical energy, and then which is able to create electrical energy. Alright, so it basically eliminates the other energy transformations for like when you burn coal. So for example, when you burn coal, we're taking the potential energy or the chemical energy that's locked up into the coal, and we're going to burn it, so we generate heat, alright, from burning that coal. And when you burn it for heat, what we want to do is transfer that energy into the water, okay, which is then turned to steam, and we fire that steam at a high rate of energy, all right, kinetic energy, which then turns a turbine. Okay, so with wind energy, what we're doing is we're knocking out all these energy transformations and we're simplifying it. Remember, there is no such thing as 100% transfer of energy. So the fewer amount of energy transformations, the fewer amount of energy that's lost. Alright, so wind is great because it takes the kinetic energy of the wind, right, transfers it to mechanical energy, which is the turbine, to generate electricity. So this way of generating energy is very efficient, and that's what wind energy is. Alright, so how does it work? Alright, we're using the kinetic energy of the wind, and here's our turbine. These blades literally just spin and rotate. Alright, and they're connected to a rotor. Alright, here's the rotor right here. And that rotor turns a generator, which is here's your generator, which is connected to a coil of wire, which spins to generate electricity. And you might notice here is D, which is called the gearbox. And what the gearbox does is it takes this rotor and it accelerates the spinning of that rotor to generate a little bit more electricity within the generator. Alright, so that gearbox is an integral component, but if you notice here, very simple process. Using the wind to turn a turbine, that rotor is connected to the turbine, which is connected to a generator to create electricity. Alright, what's interesting is a lot of people think that the faster those turbines spin, the more energy that you're going to create. It's actually the opposite. There's an optimum output, alright, for wind turbines. And if you notice here, kilowatts produced is along the y-axis here, and we're going to max out around 60 kilowatts produced. But that occurs at around 13-14 miles per hour for wind speed. Alright, the faster the wind speed, at some point here, around 15 miles an hour, you're actually going to start creating less energy. And at some point, the turbine is going to shut off altogether. What this does is it protects us from thunderstorms, hurricane winds. The turbine doesn't spin as fast as it possibly can. Alright, it might break. It might cause mechanical failure. So what they're programmed to do is, at a certain amount of wind speed, literally shut down. Okay, so it's not the faster the better. There's an optimum range here for power output when it comes to the spinning of a wind turbine. Where in the U.S. is the greatest potential for wind energy? If you take a look at this very important map here, you'll notice that there's 2 or 3 places that are optimum for wind energy. Right away, it should stick out to you that the wind belt of the United States in the center of our country is perfect for wind. Alright, these are the places where it's windy most of the time. Alright, and then also on the shorelines of the United States, you will get enough wind that it makes it economically viable to put wind turbines and wind farms. Alright, and you also notice here in the Great Lakes area. All right, so there's really two places, coastlines and the wind belt of the United States. So you should ask yourself, why these two places? What is it about these two areas that make it perfect for wind? And this is a brief lesson on meteorology, okay, and I'll try and make this pretty quick. What we're going to do here is draw the beach, okay, get you all excited for going to the beach this summer. And then we're also going to draw a mountain and a valley. And let's name this mountain the Rocky Mountains. And let's name this valley the Great Plains. Okay, this lesson on meteorology is the heating of two different surfaces. For example, during the day at the beach, the sand is going to heat up a little bit faster than the water. So air is going to start rising over the sand. Well, in turn, air can't not exist at the surface, so air needs to be replaced. So it comes in from the ocean. So you have what's called a sea breeze. Right, air coming from the ocean. Alternatively, at nighttime, the sand will cool quick and air above the water will rise. So air gets replaced from the land. So you have a land breeze. Nevertheless, you always have a breeze, day or night. There's always air moving because of the differential heating of these two surfaces. So this is where we're going to put our wind turbines. We'll put it either offshore or we'll put it just on land, because it doesn't matter to the wind turbine whether the air is coming from the land or from the ocean. As long as air is moving, there's wind. Okay, so we'll put them in those locations on coastlines. Alternatively, look down here during the day, all right, at the Rocky Mountains. You have two different surfaces. You have rock and you have soil. All right. During the day, the air above the rock is going to heat faster and therefore rise. So you have air being replaced from the valley. All right. Over the course of the nighttime, you have the opposite. All right. The valley will hold its heat a little bit longer, and air above the valley will rise, and it'll get replaced from the mountains. So here is a second place where we'll build our turbines, at the mountain and the valley provinces. All right, so because of that differential heating and cooling of two different surfaces, we have air moving in these places, coastlines and in valleys. So if we look back, here's where we build our wind turbines. All right, here's the Rocky Mountains, and so right in the Great Plains is a great place for wind, and also on the coastlines. Okay. So if we look at the existing wind installation in the United States, there you go. You have the wind belt of the United States with Iowa, Minnesota, Texas, and Colorado really taking advantage of this resource, and then those states with coastlines, New Jersey, Massachusetts, California, Oregon, and Washington, really taking advantage. Doesn't really work down in the southeast, all right, where there's it's just so warm. The difference between the heating and cooling rates really isn't there. Okay, so it's not really a good place for wind down in the southeast of the United States. So at the top 10 states, you're looking at Texas, all right, Kansas, Montana, those in the wind belt. Pennsylvania, you will see wind turbines as you get into these mountainous regions. If you take 309 or the Turnpike North, you'll start seeing wind turbines as you get into these mountain and valley provinces where there's wind at enough scale and enough reliability that you can get energy out of them. So you'll see these bands as you either drive west or you drive north and west. And then along Erie here, because of the land and the water, differential heating and cooling of those surfaces, you'll see wind turbines in and around the Erie area as well. But when it comes to Pennsylvania, we don't invest too much. All right, we're 22nd in the United States. If you remember, we're a coal and a nuclear state, so wind isn't really something we're too heavily invested in. However, it does provide some supplemental energy to our state. Okay, but when you look at the world, we have been surpassed by China. Okay, China leads the world in wind generation. They have recently surpassed the United States within the last 5 years. Okay, now, other countries of note. Germany does a real good job with wind. All right, they might not be generating as much energy as the United States and China, but remember that their country is a lot smaller. They get a tremendous amount of their personal energy out of wind. Okay, and they're very mountainous, so it's the mountain valley provinces where they're installing these wind turbines and wind farms. All right, wind energy systems, you can have wind energy systems on the small scale. All right, you can use it for your personal home to supplement existing energy sources. All right, you're never going to use a wind turbine at your house for all your energy needs. However, you can use it to supplement an already existing energy source. All right, take a little bit off your energy bill. You can use it on the community scale. Okay, there's areas where there's a development and they put in a small wind system. All right, so only that local community can benefit. All right, and then you can use it at the power plant scale. Okay, hook up what's called wind farms and generate a tremendous amount of energy at the utility scale. However, if you remember about coal-fired power plants, all right, a coal plant is somewhere around 1,000 to 2,000 megawatts of energy. All right, we're looking at a lot smaller of production scale when it comes to wind. All right, so here we have one at our save house. All right, this thing was installed on the side of our building to power our landscape lights, which you can see down here at the bottom of the picture. So that thing spins and generates electricity, which is stored right on the other side of this wall in a battery that's connected to the wall, and then that actually comes out right here, and there's a cable underground hooked up to our landscape lights, so you can see when you're coming to a save meeting. Okay, there's all kinds of innovative designs for wind turbines. They don't have to be the blades like you traditionally see. There's all kinds of different designs. Here's a rotating drum. All right, here's a more stylish one on the house in the bottom right. This is harnessing the energy of the traffic that's going underneath this this underpass here. All right, so with that energy, they might be powering these street lights or maybe a local stoplight, something like that. Okay, here's something more on the community scale. This is Atlantic City, so you can see the casinos in the background there. But in Atlantic City, on the coast, at a community scale, this is the wastewater treatment facility for the city of Atlantic City, and they're being powered completely on wind energy. All right, so here this would be something at the community scale. All right, if you notice, there's very little impact to the area having these things here. All right, and then you can have them on a utility scale, and these are your big boys. All right, these are the ones that are hundreds of thousands of pounds, and they're just absolutely gigantic. Okay, and if you string a whole bunch of these together, you can generate some serious electricity at a utility scale. This is one that is in Palm Springs, California, taking advantage of the Mountain Valley province and generating tremendous amount of energy from this wind farm, and this thing spans for miles. This picture really does it no justice. Alright, where do you place a turbine? You might notice them on the tops of mountains, and they're as tall as they are for a reason. As air passes over a mountain, alright, it can become turbulent from having to go and bump into more air that's all trying to go over this mountain. So what you want to do is you want to tap into the most steady, sustained wind at a certain mile per hour. So above those turbulent winds that are all bumping into each other, trying to get over the mountain, you want to tap into these winds that are a little bit higher than that are more or less steady and straight. Okay, and some of them actually have to compress. They don't actually bump into each other, but as they compress at the top here, they have to actually accelerate so they don't bump into each other. So there's this place at a certain height above a mountain that has the optimum range for a wind turbine. All right, you want to get those winds that are accelerating over top of the mountain but not bumping into each other. All right, so that's why they are as tall as they are and where they are. When it comes to your house, you have the same situation. All right, you want to place your wind turbine away from any obstacles, away from any turbulent areas. All right, you don't want to put it near a tree where wind is going to be hitting the tree, and the turbulence is going to impact the ability of it to turn the turbine. All right, let's look at this thing on an industrial scale, and this is the size of one blade. All right, these things are absolutely gigantic. Here are a bunch of engineers loading this thing onto a crane that'll pull it up on top of the shaft. All right, and here's an operator at the top there guiding it into position. All right, there's a lot of benefits to wind energy. All right, there's lower impact. And what I mean is that there's zero emissions. These are completely green. They're completely clean energy. All right, we don't have to boil any water. We don't have to turn it to steam. All right, there's zero emissions. There is no carbon dioxide. These are completely green. All right, there's no water used. All right, you're still able to use the land. If you notice here in the lower right, we can farm right around these things. Very little impact. If you build them off the coast, you can still recreationally fish and boat around these things. All right, you're still able to use the land. All right, it's domestic. We have areas of the country that we can utilize. It's completely sustainable. And it provides jobs. All right, there's consistent maintenance of these things. There's construction and planning and operation. All right, there's engineering. All right, so it provides jobs. Lots of benefits to wind energy. You should know by now, as there are advantages, there are disadvantages. What if the wind isn't blowing? All right, that's the first one everybody thinks about. All right, we're working with an intermittent energy source, which makes it difficult for investors to want to go with this type of energy. All right, why not go with coal or natural gas, something that we know about and that is predictable and reliable? All right, the cost is still a little bit higher than traditional energy. This still isn't mainstream. Okay, traditional energy sources like coal are still maintaining a cheaper price. All right, we don't have the infrastructure, and this one I want to put a big asterisk next to. This is one of the major problems. Most of the areas that are great for wind are out in the middle of the country. All right, North Dakota, Iowa. We don't have the infrastructure, the power lines built in place to capture that electricity and then move it to the East Coast where most people live. All right, we don't have the grid. The grid is set up right now for our coal-fired power plants on the East Coast. All right, we can capture the energy, we can get it, but we don't have the infrastructure to move it. All right, and that's a huge problem with wind energy in the United States. There are environmental impacts. All right, people don't like to look at these. They call them eyesores. All right, they create noise pollution, which is very real. All right, if you can think about the noise that this might make, that low, droning, constant woo, woo, woo. If you heard that on a daily, nightly, weekly, yearly basis, it may have a physiological effect on you. All right, so the noise pollution is real. All right, as is its impact on wildlife. All right, there are some minor impacts on wildlife, and then what if it catches on fire? You literally have to watch it burn, keep people away, because a couple 100,000-pound wind turbine is going to fall down. All right, so there's really not much you can do when it comes to a burning wind turbine. All right, so here you go. You got a graph here that shows you wind energy that started out early in the morning and then picked up during the daytime, but for whatever reason around noon, the wind stopped, and now you're not generating any electricity for a certain period of time. So this intermittent characteristic of the wind makes it unreliable. All right, if you can guarantee wind all day long at a constant rate, it would be a whole different story, but we cannot do that. All right, when it comes to bird impacts, all right, wind turbines really play a small part. A lot of people think that these things kill birds and they're going to cause extinctions of certain bird species. But if you're really concerned concerned about birds, we should quit building buildings and windows, because they by far cause more bird deaths than wind turbines. Alright, and this slide here is just to show you that most of our population is over here on the East Coast, but all the way over here is our wind farms and our ability to capture large amounts of energy. We don't have the electricity infrastructure to carry it over to the East Coast where most people live, and that's a huge problem with wind as an option for electricity. Alright, sticking with bird deaths here, the really only issue that I see with killing birds is if you have a little field mouse here in the middle of the picture, and that field mouse is out here on the street where it's very deadly for a field mouse to be, and you have a hawk that dives down here to get that field mouse, and that's when you might have a bird death. Other than that, these wind farms really don't generate much impact on wildlife, but you will hear conversations about that. When it comes to wind turbines, they produce noise, this low droning sound. All right, and the closer you get to the wind turbine, the louder it gets. All right, so for example, according to this image here, somewhere around 400 meters, it might sound like a running refrigerator. A very low sound. However, the closer you get, all right, it might sound like a mid-size window air conditioner. Pretty loud. And then the closer you get, a vacuum cleaner. So all wind turbines, when they're constructed, they have to abide by something called a setback. All right, and a setback is a distance that a wind turbine is allowed to be from a particular property. So, and there's no worldwide agreement on the distance that a wind turbine has to be set back. All right, so you might see something from 1,000 feet to 2,500 feet that a wind turbine has to be placed away from an existing structure like a house or a business. All right, so that setback becomes important because the closer you are, the louder it gets, and people can have some real physiological effects from the noise pollution that these things generate. People have been known to experience headaches, loss of sleep, aggravation, things like depression. Real physiological effects from the noise pollution that these things generate. So the setback rule is something that we need to consider. Alright, others just don't like the way they look. Okay, and that brings me to my last slide here at the New Jersey shore. There was a proposal for a series of wind turbines off of the coast of New Jersey, a very populated region. All right, so all these shore towns were going to benefit from offshore platforms that had wind turbines on them, and then the electricity would be brought onshore to these shore communities. However, this project continues to be fought against by local people who don't want to lay on the beach and look at wind turbines. All right, they want to lay on the beach and look at the vast ocean and its natural beauty. So, these things are really difficult to get past. All right, people want wind energy. They really believe wholeheartedly. They know it's a green energy source. There's no emissions, no water, but it's that NIMBY syndrome. All right, not in my backyard when it comes to wind energy. So this is a tough one, and hopefully this mini lecture here gives you a sense on the advantages and disadvantages and the basics of wind energy.